Welcome to the deep dive. Today we're plunging into Jupiter. NASA's Juno spacecraft has been sending back some amazing stuff.
It really has.
And Binsies.com has been digging through that data. They've flagged some pretty wild questions.
Oh, yeah. Like what?
Like, could Jupiter's huge storms actually be a blueprint for weather on, exoplanets?
Interesting.
And are its jet streams really faster than a bullet train? Let's get into it.
Okay. So Juno got there in 2016, right? And it's had to survive some seriously intense radiation belts. It's brutal out there.
Right. And it's got specific tools for this.
Exactly. It uses things like a microwave radiometer. Basically, it lets us see heat deep down below the cloud tops, and also infrared mapping tools, really peering inside.
So what's one of the first, surprising things it found?
Well, get this. The temperature right at Jupiter's North Pole, around 11 degrees Celsius.
11 degrees. That sounds almost warm. For Jupiter, anyway.
It is surprisingly warm. Definitely challenges some assumptions we had about how heat moves around on these giant gas planets.
So, okay, this warmth kind of forces a rethink.
Precisely. It's a key piece of the atmospheric dynamics puzzle we didn't quite expect.
Okay. Now, those jet streams, Binsies.com mentioned the speed comparison.
Yeah, they clock them at about 161 kilometers per hour.
So faster than some bullet trains, maybe? That's pretty quick.
It's undeniably rapid, yeah. Maybe not every bullet train, but it's fast.
Yeah.
And, connecting that back, these speeds tell you about the sheer energy churning away inside Jupiter's atmosphere. It's immense.
Absolutely incredible. And the pictures from the poles.
Yeah.
Just stunning. That huge cyclone you mentioned.
Oh, yeah. Visually, it's captivating. There's this massive polar cyclone, and it's literally surrounded by 8 smaller vortices.
Wow, 8 of them.
And they're not just sitting there. They actually oscillate and seem to sort of bounce off each other.
Balance, really.
It sounds weird, but yeah, that kind of large-scale storm behavior, it's like a natural laboratory. It helps us refine our storm models.
Storms here on Earth.
For Earth, absolutely, but also potentially for understanding weather systems on, distant exoplanets.
So studying Jupiter's superstorms gives us clues about alien weather.
You got it. The basic physics involved probably has overlaps. It's a great comparison point.
And it's not just Jupiter itself giving us surprises. Its moon, Io, has been pretty lively too, hasn't it?
Definitely lively. Juno found evidence suggesting about 10% of Io's crust hides still warm magma.
10%. So it's geologically active underneath.
Very. Think of Io like a planet with a kind of leaky radiator constantly venting heat from deep inside out to the surface.
That's wild. And didn't it have a huge eruption not long ago?
It did, yeah. Late 2024. A really significant one. Actually, one of the most powerful we've seen there.
Wow. What kind of impact did that have?
Well, huge amounts of lava and ash spewed out, dramatically changing parts of the moon's landscape. But it also makes you wonder, right?
Wonder what?
How these big eruptions affect Jupiter's whole charged particle environment nearby. And, what hazards that might pose for future spacecraft missions going into the system.
Good point. It feels like Juno just keeps opening new doors, finding new things, and it's still going.
It is, yeah. The mission's trajectory takes it through September 2025, continuing these close polar passes.
Until Jupiter's gravity eventually.
Eventually, yeah. Its gravity will pull it in. That'll be the end of the mission. But until then, who knows? Every orbit could reveal something new.
It really makes you wonder what else is hiding there, waiting in those final flybys.
Absolutely.
And this whole mission, it's not just about Juno, is it? It feeds into future plans.
Exactly right. What Juno finds is crucial for planning and refining missions coming up, like the European Space Agency's JUICE mission and NASA's Europa Clipper. It paves the way.
So stepping back then, we've got Jupiter's incredibly dynamic atmosphere, these super fast winds, the weird polar cyclones, and then this surprisingly fiery activity on its moon, Io. Juno's really pushing our understanding.
No doubt about it. The boundaries are definitely being pushed.
Okay, so final thought then. Considering all this, intense activity we're seeing just in the Jupiter system.
Yeah.
What kind of truly unexpected things might future deep space missions uncover when they look at other gas giants and their moons way out there across the universe?
That is the thrilling question, isn't it? What other completely unknown interactions or phenomena are waiting for us? It's an exciting time for planetary science.